Hi, Daniel Westgate from Brilliant Ideas, and in this explainer video we're going to be highlighting the importance of material stiffness with regards to crane outrigger mats. A lot of competing systems will talk about the compressive strength of their material, but not the stiffness. And Ground Conditions for Construction Plant October 2014 does actually state the two differences between strength and stiffness, whereby strength, the hierarchy would be steel, aluminium, nylon, polyethylene and timber. But in regards to stiffness, which in our opinion is the most important, the hierarchy is steel, aluminium, timber, nylon and polyethylene. And what we have here is two types of mat systems. One is a competing system, which is the UHMW-PE, which is the ultra-high molecular weight polyethylene, which is a very common system used in the construction industry. This particular module is 1.8 by 0.6 metres wide and 50 mil deep. It weighs 52 kilograms, and according to the literature from the company we purchased it from, it's rated at 54 tonnes. When it works as a system, it does actually claim a higher value than that. And what you're looking at, this red thing here is our test rig. And what we're going to do, we're going to run a load test down the centre of the mat to actually measure deflection and actually see how stiff this material is. Now, if I can just come around here, we'll come to our ALIMAT module, which is manufactured from aluminium. And this is our system manufactured through extrusion, which is 580 wide by 60 mil deep. And this particular module is 1.74 long, and it weighs 38 kilograms, so actually lighter than the polyethylene system. What you can see on the top are these rigid steel plates, and we've had these manufactured specially for this test, and it's been designed to actually simulate how a crane outrigger would apply the load. So it's very, very stiff. So it's actually applying a 500 mil by 500 square contact load to the module. So let's begin with the test. On this particular one, we're going to take it up just to 1 tonnes. So Philip, if you could start pumping. You'll see the gauges, they should equalise, and then the load will start being applied through the mat system. And Philip, if you can see the values, if you could read them out.
That's 36.
That's 36 kilograms.
61.
Now, from the FEA that we've had carried out simulating a similar test,
100.
we are expecting the polyethylene
300.
mat system to deflect significantly, and we're not expecting
400.
the ALIMATS system to deflect much at all.
500. 600. 700.
So you can already see significant deflection with the polyethylene system. If I crouch down here, I can already see a gap, which would indicate that at this point the load is simply triangulating straight through the outrigger and subsequently not actually spreading load. So you're going to get a high concentration of pressure below the mat surface.
That's a tonne.
So that's 1 tonne. And you can see there is significant deflection, and it will be recorded as to exactly what that is. So as you can see, I think what this highlights is some of the claims made by polyethylene systems are questionable with its ability to spread load. We don't dispute its compressive properties, but obviously on soft ground, we do question its ability to work effectively as a crane outrigger mat system. Okay, so we've taken some readings on the actual deflection from the test where we've applied a 1 tonne load onto the polyethylene mat and the aluminium mat. And the recorded deflection on the top of the polyethylene, because there is actually a gap between the polyethylene and the outrigger plate, and the recorded deflection from pre and post test was 102 millimetres, which we think is very significant when you're only thinking about a 1 tonne load, whereby the recorded deflection on the top of the ALIMAT module was just 2 mil. So again, you know, we do think that is a significant deflection when you actually consider the intended use for this system. Now we just want to have a quick look and see if the profile is going to bend back into its original form or whether it's going to stay bent. And if it stayed bent, it's actually reached its elastic limit, which is simply not ideal. And some crane operators we do speak to when they use this system, they say the only way to get them to bend back is to turn them upside down and use them in the upside down format. So Philip, if you can just release the load off the test rig. So you can see that is coming up. And then just pump the rams up. Right, we've got some clearance here, so I think we can slide it out. Okay, so we're just going to pull this steel plate out the way. And I don't know if you can see there on the camera, but there is still a visible bow on this 1.8 metre long polyethylene mat, which clearly indicates it hasn't sprung back to its original shape and subsequently, in this particular case, has reached its elastic limit.